So we have two kinds of nature of the matter over here. That is, one is wave nature and another one is particle nature. The electric field is the one which is very much responsible or necessary for an electrons to be emitted out of the surface is called as field emission. Photons are electrically neutral, therefore the rest mass of the photon is said to be zero. So this is also very important point. It comes under particle nature of what? The light. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 11, and chapter name is Dual Nature of Matter. So in today's class, we are going to deal with the matter, that means here we are considering a light waves, and the dual nature of that light, what we consider. So now here we have got the discovery of the phenomenon. We know what is interference, diffraction, polarization, all these. The discoveries of these concepts gave the existence to wave nature of light. And later on, some of the discoveries like cathode rays, X-rays, which are having like stream of particles, they were told that they exhibit the particle nature. Okay, so we have two kinds of nature of the matter over here. That is, one is wave nature and another one is particle nature. Okay, so both these concepts together gave the existence for a dual nature. So both also gave an existence for the dual nature. So here in this chapter we completely study about the double nature of the light. Okay, so next is electron emission. So when we just went depth into this concept of the dual nature, first of all, the light means to say that there is a presence of electrons over there. It is a charged particle, so there is a presence of electrons, right? So now electron has to be emitted out of the metal surface, which is called as electron emission. Okay, so the emission of the electron out of the metal surface is with the help of certain external energy, and that external energy which is required, based on the external energy which is required just to emit the electron out of the metal surface, it is classified as, one is field emission, photoelectric emission, third one is thermionic emission, and then we have secondary emission. So let us list according to the external energy what is required. One is thermionic emission and field emission, third one secondary emission, fourth one photoelectric emission. So what do we learn here? Liberation of electrons from the surface of the metal is known as electron emission. Okay, so based on the external energy which is responsible for this effect, it's been classified into, one is thermionic emission, field emission, secondary emission, photoelectric emission. In case of thermionic emission, we consider temperature. As we increase the temperature, or as we raise the temperature of on a metal surface, when it is raised, what happens? The electron is just ejected out of the metal surface when enough temperature is falling on it. Next is field emission. Field emission, we just talk about the electric fields. The electric field is the one which is very much responsible or necessary for an electrons to be emitted out of the surface is called as field emission. Third, it is secondary emission. When it comes to secondary emission, which means to tell that already the electrons which is pre-existing, that is the one which emits the electrons which is present on the metal surface. The electrons of higher energies goes and touches, that is hits to the electrons which is embedded in the metal surface, and it is allowed to eject out of the metal surface. Fourth one, it is photoelectric emission. The photoelectric emission means, the concept is also important and it's very easy. Everywhere you study this, it's a common type of emission where the light falls on the metal surface and the electrons from the metal surface, when the light's intensity is more on the metal surface electrons which is present over there is just eject out of the surface of the metals. That is by photoelectric emission. That concept is called photoelectric emission. Why photo? Because the light is the one which comes in, that is, which occurs in discrete packets of energy is called as quanta. Photons, it is called as photons. The photon of light which is incident on the metal surface is used to eject the electron out of the metal surface is what we study over here. Okay, so these are the 4 types of electron emissions with respect to the external energy. Next, we are going on to Halvox as well as Leonard's experimental observation. So it was considered that Halvox as well as Leonard, first of all, Leonard and Halvox both also underwent the same type of experiment. That is, the UV light was allowed to fall on the cathode, which emitted the electrons. It was the UV light or the rays, it was emitted towards the cathode. So the electrons whichever was emitted out of it, it used to pass towards the anode, and due to this there was generation of photoelectric current. Due to the photons, the current which occurs is called as photoelectric current, that is due to the escaping of the electrons from the one plate to the other plate, from the emitter plate to the towards the collector plate was the consideration was taken by Halvox as well as Leonard. Okay, wherein Halvox used the zinc plate as the emitter plate. Okay, that's all was the difference. Other than that, the concept was the same. The UV rays was allowed to fall on the emitter, and the emitter emitted the electrons towards the collector. The collector collected the electrons, which resulted in the photoelectric effect. So, when this concept has been thought or when this concept has been discussed, we just get into one concept, and that is nothing but threshold frequency. Threshold frequency. So, the frequency of certain, that is the intensity of the frequency of the light should be in such a way that when you just increase for the minimum frequency, the electrons will not easily escape from the emitter plate. On increasing slow by slow its frequency, what happens to the emitter plate? It starts emitting the electrons. The starting of the emitting of the electrons, that concept is known as threshold frequency. It is the minimum frequency. Okay, the threshold frequency means we tell it as it is a minimum frequency at which the electron just starts escaping the emitter plate. Understood? So that concept arises when we consider this Halvox and Leonard's experimental observation, which was actually the photoelectric effect observation. Okay, for this there were certain conclusions. That is, it was told that the current is directly proportional to intensity. That is, the photoelectric current directly proportional to intensity. The saturation current is directly proportional to intensity. The photoelectric current is directly proportional to intensity. The saturation current also is directly proportional to intensity is what was discussed. So, along with this threshold frequency, there was something called as a stopping potential. So, what is it? Stopping potential. So, these are the important concepts for 1 mark what you'll have to study, because this time for dual nature of matter concept, that is a chapter, it comes for 5 marks in a split question manners. So, you will have to study all these split questions. Okay. So, in case of stopping potential is the potential at which your current, that is the photoelectric current, becomes zero. When the photoelectric current becomes zero, at that movement, at that point, what is the value of potential? That is known as stopping potential. Stopping potential is the potential at which the photoelectric current becomes zero. So, I hope these two are very clear for you now. One is threshold frequency, another one is stopping potential. So, here you have got current is directly proportional to intensity, saturation current is directly proportional to intensity, and the kinetic energy, how does it vary? It increases linearly as the frequency is increased. Okay, kinetic energy increases linearly as the frequency of the incident radiations increases. Okay, so those are the concepts of Halvox and Leonard's observation. Next, we have got Einstein's photoelectric equation. Okay, so before studying this photoelectric equation, we know that the UV rays or the any incident radiations is incident on the emitter plate in such a way that it comes in quanta, and each quanta has got its energy called as h nu. Okay, so now we know that there is a radiations which falls on the metal surface. So certain, that is radiations is given by h nu, energy is h nu. So it has to do some work here. That means it has to eject the electrons out of the metal surface. So the work has to be done, which is given by a work function, and this phi naught is called as the work function. So work function is nothing but it's a minimum energy which is required by the light, incident light, just to eject the electrons out of the metal surface. And how does the electrons move? It just moves. It does certain work, that is the movement. During the movement, what energy stays? It's a kinetic energy, right? So there exists a kinetic energy also. So you, on the total, you just calculate it as, you know, h nu on the total is equal to the work function plus the maximum kinetic energy is what you have to know. For this, we know that you have to get the kinetic energy because we are checking the Einstein's photoelectric equation. So for that, maximum kinetic energy is equal to, you have h nu minus work function. So we can consider this as half mv square. Velocity will be maximum because we are considering maximum kinetic energy. H nu is the frequency, h is the Planck's constant, phi naught is the work function. So this is one of the most important equation which may be asked for 1 mark, Einstein's photoelectric equation. So now we have got the particle nature of light. Once we study the particle, we are studying the dual nature of matter, which means to study, we need to know certain bits and pieces of the particle nature concepts, right? So for that we study light. When it is interacted with matter, it behaves as if it is made up of packets of energy, which is called as what? Quanta. And each quantum has got its energy. I told you energy is equal to h nu. Nu is the frequency, h will be the Planck's constant. Okay. Next you have the particles which is associated with quantum energy is known as photons. So we call it as the quanta, that is the energy with h nu is nothing but, you can either call it as photons. Okay, the photons are having the energy which is equal to h nu. Then next we have photon energy and momentum depends only on the frequency of radiation, that is nu. Okay, the photons energy, the energy of photons depends upon the frequency of the radiations which is incident on the plates or the metal surface. Next we have the photons are electrically neutral. Remember this, the photons, this time it was asked in preparatory regarding the rest mass. Okay, so photons are electrically neutral, therefore the rest mass of the photon is said to be 0. So this is also very important point. It comes under particle nature of what? The light. Okay, so these are the concepts about your dual nature of matter. And next we are jumping on to de Broglie wavelength. So in case of de Broglie wavelength, we need to derive it. Okay, so the derivation goes on like this. We know that E is equal to h nu equation 1. That is the energy of what? It is the energy of photons. We even know that energy in mass energy relation, give it as E is equal to mc square equation 2. Equate equation 1 and 2, you have h nu is equal to mc square. Okay, so now we have m is equal to h nu divided by c square. Okay, so consider this as equation 3. Now we know that P is equal to mv, momentum. Okay, so V can be replaced by V is equal to velocity of light, since we are considering light here in this chapter, dual nature of matter. So it is P is equal to m into c. For substitute for this equation for m, P is equal to h nu divided by c square into c. Okay, so we have 1c goes with 1, so P is equal to h nu can be even written as c by lambda. So we have C by C into lambda, where lambda cancels. So P is equal to H by lambda. Okay, so even I can write lambda is equal to H divided by P as the wavelength. Having so many things, now we also know that having these many concepts, we also know that this is for the photon, and for the particle we have, for particle the equation turns out to be lambda is equal to H divided by, instead of P we can write it as M into V. Okay, now we know that kinetic energy is equal to half mv square, right? So now 2k is equal to mv square and P is equal to mv. V becomes P by m. Substitute here. So 2 times the k is equal to m into P square by m square. Cancels. So it is 2k is equal to P square by m. Okay. So now retain for P. P is equal to root of 2 times the km. We can even write 2 times k into, or we can even write mv is equal to root of 2 times the km. So you can substitute this equation, call this as equation 4 in case of your particle, that is lambda is equal to h divided by mv. For that, therefore, lambda is equal to h divided by root of 2k times the m will be your answer. That is de Broglie wavelength. The equation for de Broglie wavelength is this one. So you will have to do these many things if they ask you derive the equation for de Broglie wavelength. And next we are going on to Davison and Germer experiment. In Davison and Germer experiment, it is just the experimental setup, that is there is a filament gun which is connected to low tension over here, and you have got a high tension which is placed over here, and for which the anode is connected, through which the electrons is getting collimated with the help of this anode, and it falls on the nickel crystal. And once it falls on the nickel crystal, it is deviated with an angle theta, and that is detected by a detector, and this detector is connected to a galvanometer. Okay, so the setup was undertaken to confirm the wave nature of matter. Why was the Davison-Germer experiment considered? In order to conclude the wave nature of matter. Okay, next is the filament is heated by a low voltage power supply. Okay, so you have, first of all, you have to heat this filament. Okay, next, the electrons are emitted by the filaments. When suddenly the low voltage is supplied, the filament starts heating up, because of which the electrons are emitted by the filament, and it is accelerated with the help of any desired velocity it wants by applying a high power supply. Okay, so that has been given by this. Anode A is in the form of a cylinder with a fine hole through which the beam is collimated. So through this anode, the beam is said to be collimated. The beam is said to be concised. It is collimated and it falls on the surface of what? Nickel crystal. So the crystal what we use here is a nickel crystal. So it is deviated by with the help of a certain angle theta. So the intensity of the electron scattered is measured by the detector, which is connected to the galvanometer. This is how exactly the experiment was taken up. The procedure of the experiment was considered. Okay. In today's class, we have dealt with a complete chapter of 12 nature of matter. Let us all meet in the next class with the upcoming session. Until then, have a good day. Thank you.